So here we're going to write equations for each graph shown. And if you look at each of the four graphs here, they are all V-shaped in nature. So we will be able to model these with a two-variable absolute value equation. So all of these I will write of the form where the y value will be determined by taking the absolute value of x, but we will be able to subtract some h number perhaps, and that h number there is always going to correspond to some sort of a horizontal translation by that number of units. And then we may also add some sort of a constant on the outside right there, which I'll denote with k. And that k right there is really going to correspond to a vertical shift or a vertical translation by k number of units. We may also multiply by some sort of a negative value, and if we do have that negative value, it's going to reflect the graph over the x-axis. And then finally, we may have some sort of a constant a, and that a right there is either going to be a compression factor or a stretch factor. But in both cases will always be a vertical compression or a vertical stretch, and it depends on whether or not the absolute value of a is going to be less than 1 or greater than 1 to determine that. So to be able to write in the absolute value equation of that form that I have expressed right here, the biggest thing you'll want to do first is identify your translations. In other words, figure out the horizontal and vertical shift amounts. So with this first graph right here, this absolute value graph, compared to 0, 0, the graph has shifted left exactly 1 unit, and it's also shifted up 4 units. So what we're going to expect for this equation then is that inside the absolute value is going to correspond to the horizontal shift. So since it did shift to the left 1, then we're going to subtract -1, and so we're actually going to see a plus inside the absolute value whenever you're shifting to the left. It'll be a minus inside the absolute value if you're shifting to the right, and then the 1 because that's how many units we moved. And then any vertical shift, so if we move up or down, is always going to be outside of that absolute value that gets added or subtracted. If it does move up, it's going to be a plus, and so in this case, it'll be a plus of 4. The absolute value graph is facing upwards, or the V is facing upwards, so we don't have any reflection going on. And then also, you'll notice that if you follow the slope of this V, it's just really just at a slope of 1 or -1, so it is not stretched nor is it compressed compared to y equals absolute value of x. So that right there is going to be the finalized equation that defines what we're seeing in the graph right there. With the second example right here, you'll notice that the vertex is really just to the right 1 unit of where the origin is at. And so we're going to expect then that because it's a horizontal shift that we're going to see something inside the absolute value. And what we'll see is we'll see a subtraction of 1 because it moved to the right, hence the subtraction. And then also you'll notice that it's upside down, so we're definitely going to see some sort of a negative number that gets multiplied with the absolute value quantity. But other than that, it's just going at a slope of -1 or 1 on both sides. So it's really just kind of like a -1 in front right there, which you don't really need to write the 1, because if you just write a negative, we know that it's a -1 multiplying right there. So that gives you the finalized equation for that particular graph there. For this third example, you'll notice that the vertex is just a shift down 2 units from the origin. So we'll expect right here that we'll just have the absolute value of x, because there is no horizontal shift. We're not moving left or right. Because it did move down, though, outside of that absolute value, we're going to have a subtraction of the value of 2. You'll notice that the absolute value also is facing upwards, so you're going to have some sort of a positive constant right there. It will not actually be the number 1, because you'll notice that actually everything did get stretched a little bit, and if you kind of follow that slope pattern right there, it's really following this pattern of a slope of 2, and so we'll see that we'll have a vertical stretch factor there of a positive 2. That gives you that final equation right there then. And then finally, for the very last one right here, you'll notice that we have coordinates -2, -3 for where the vertex is at. So what that's going to correspond to then is this -2 is a horizontal shift left 2. So inside the absolute value, you're going to see the quantity of x plus 2 when it moves to the left 2. And then when it moves down 3, you're going to see a subtraction of 3. And then the last thing that we'll want to incorporate right here is any sort of a factor or reflection that may be going on. There is no reflection since the V shape is facing upwards, but you will notice that it's a little bit flatter than a pancake, because if you do follow the slope pattern of this, it seems to kind of have a slope of 1/2, and that indeed is the compression factor, that the graph is compressed by a factor of 1/2 compared to just y equals absolute value x.